Okay, this is going to be Unit 6 Notes Part 2. I'm going to be just running through these. Just remember, try to give them a shot first, see what you guys can come up with, and then watch the solutions. If not, that's fine. Just make sure you pause, kind of go at your own pace. I'm just going to be talking fast to make the video as short as possible. So, with number 1, Jessica bought tickets to a movie. Children's tickets cost $5 each, and adults tickets cost $8 each. So, if children's tickets are $5 each, I can say 5 5 times however much a children's ticket was plus 8 times however much an adult ticket was $101 altogether. The cost for 16 tickets, well, now I know she bought 16 tickets, so I can say the number of children's plus the number of adults is equal to 16. And then there are two equations, so we can use this one. I'm going to go ahead and use elimination just because it looks like it'll be a little bit easier. If I want to get rid of the c's, I have a 5 here, a 1 here. I need to make this into a negative 5 so that the c's will go away. So I multiply my entire bottom equation by negative 5. Top equation stays the same, so it's still 5c plus 8a equals 101. The bottom equation becomes negative 5c minus 5a equals negative 80. C's go away, so I have 3a equals 21. Divide both sides by 3 and 3. So I have 7 adults that went. So if I have 7 adults, I know altogether I have 16, so then I must have had 9 children. Looking at number 2. For a school play, 340 tickets valued at $810 were sold. So we know there's 340 tickets altogether. They're worth $810. Some cost $2, some cost $3, so I'm going to call my $2 ones X, and I'll call my $3 ones Y. How many tickets of each kind were sold? So I know total there are 340, so I can say X plus Y equals 340 tickets altogether. They were valued at $810 apiece. Well, my X tickets cost $2, so 2 times the number of X tickets that I have, plus 3 times the number of Y tickets that I have, should equal the total value altogether. And there again, we have elimination may be the easiest way. You can also do substitution. Graphing would be pretty fun with this if you really like y-intercepts that are like 810 or something. So if I want this negative 2 to go away, I'm going to make my x's go away. So multiply the entire top equation by negative 2 to the x, to the y, and to the 340. So I'll have negative 2x minus 2y equals negative 680. I can work with these two right there. Kind of leave, oh no, leave that one out. Yeah. Okay, so 3 minus 2 is 1y equals 810 minus 680 is 130. So if I have 130 of the $3 tickets, then I should have 210 of the $2 tickets, since I have 340 altogether. Okay, looking at number 3, our favorite type of problem. We've seen this one before. So we have the perimeter of a rectangle is 82 yards. So we know perimeter is 2 lengths plus 2 widths should equal our 82. The width is, so W equals, remember is usually equals, is usually means equals, is 15 yards less than the length. So I can say width is the length minus 15. There's our two equations. Since W equals L minus 15, then this W right there also equals L minus 15, so I can say 2L plus 2 times L minus 15 when I substitute in L minus 15 for the W equals 82, and it's just a matter of solving for L from there. So 2L plus, distribute your 2 to both of them, plus another 2L minus 30 equals 82. So 4L, add the 30 to both sides, equals 112. Divide by 4. So L is 28, I believe. 56. Yes, 28. So the length is 28. So if the length is 28 and the width is 15 less than that, then our width should be 13. I didn't number it, but this is number 4. On vacation, Ashley and Tracy took turns driving. The distance that Tracy drove was 115 miles more than the distance that Ashley drove. So Tracy drove the amount of Ashley's. Oops, not plus, equals, should be plus. Ashley plus 115, because she drove 115 miles more. Okay, together they drove 235 miles, so Tracy plus Ashley, oh my gosh. Tracy plus Ashley equals 235 altogether. So if I know Tracy drove the amount that Ashley is plus 115, I can substitute this in for t, since t equals a plus 115. And then I can say a plus 115 plus a equals 235. So 2a, subtract over the 115, equals 120. And then divide both sides by 2, so Ashley drove 60 miles. So if Ashley drove 60 miles, then Tracy should have driven 175. Add them up. They are 235, so that is our system of equation. Number 5. Beth has $3 more than twice as much as Mark. So Beth has usually means equals, kind of like is. $3 more, so 3 plus twice as much as Mark. So 3 plus 2m. Together they have $57. So Beth plus Mark equals 57. Okay. Then again, I have substitution because I already have b by itself. So if b equals 3 plus 2m, then this b is the same thing as that because b equals b. So I can say that 3 plus 2m, when I substitute m, plus m equals 57. So then combine my like terms. I'm going to subtract 3 over to the other side. So 3m equals 54. If I divide both sides by 3, then m is 18. So Mark has $18. And if Beth, together they have 57, then Beth should have $39. Last one, lots of words in number 6. Chad and Annie went shopping in the same store. Chad bought 4 shirts and 2 ties and spent $104. So 4 shirts plus 2 ties was $104. Andy bought 3 of the same shirts and 3 of the same ties and spent $96. So 3 shirts plus 3 ties was $96. What was the cost of 1 shirt? So we're trying to find S. So if I can use elimination and get rid of the t, then I can solve for S and be done. So if I want to get rid of the t's, I have a 2 and I have a 3. Their lowest common multiple will be 6. So if I multiply the top equation by, say, 3, and the bottom equation by -2, so that 6 minus 6 will be 0. Okay, so in the top equation, I will have 12s plus 6t equals, oh gosh, 312? Yes. And then I'll have -6s minus 6t equals -2 times 96, -192. Yes. Okay, so then 6t minus 6t is 0. So I'll have 6s equals 312 minus 192. Don't make fun, I want to make sure I get it right. Okay, so that's 120. If I divide both sides by 6 and 6, so each shirt costs $20. Done!